When it comes to a good college, we have many dreams and expectations, spacious classrooms, elegant buildings, a beautiful campus. Reaching college is also equally important. If the campus is close to a city, there's nothing like it. For some of us, the faculty is the primary concern. A set of good teaching staff is the foundation of a college. For others, the library is important. Knowledge is not just light, but also an expression of freedom. The laboratories set up with state-of-the-art equipment. Imagine a college which assists you to begin your own startups. College is a place where you can excel in sports, where you get a platform to showcase and hone your skills. Also, you will get many opportunities that will help you become self-confident and rediscover yourself. You can inspire each other, ideate, and grow together. It's not enough to just know your subjects. The real learning is in redefining them and living by them. Of course, there'll be books, exams, classrooms, but there's one important thing that you cannot be taught from books, an essential factor. That is life.
Hi, this is Divya Prasad, Training and Placement Officer, JIT Davangere. Coming to the placement part, every year we are providing the quality training for the pre-final year and final year students, kind of communication skills, aptitude training, and moreover, 200 plus students are placed every year for the topmost companies from Wipro to startup companies. I'm very privileged to work for the Jain Institute of Technology, Davangere.
Myself, Dr. Manjunath P.S. is the principal of Jain Institute of Technology, Davangere. Jain Institute of Technology, Davangere belongs to Jain Group of Institution, Bangalore. Dr. Chandraj Roychandra Jain is the chairman of Jain Group of Institution. Jain Institute of Technology, Davangere, located adjacent to the National Highway near to Davangere University. Jain Institute of Technology, Davangere started in the year 2011 with 5 branches of engineering and 1 PG course MBA, and we have 3 research centers. In JIT Davangere, we continuously strive for the quality education to the students. We have received the first rank in the year 2017-18 gold medals. We have an MOU with the R&D research centers and the industries and the companies. They continuously support us to guide the students for the research and the placement. Nearly on an average, 200 students are placed in various companies every year. We have well qualified and experienced faculty members to guide our students continuously. We have both the boys and girls hostel and the transportation facility for the students from the various locations of Davangere.
That the difference made by college experience in our lives is more than we thought. But to achieve that, you need to study in a good college that fulfills all these aspects. So even though we go to college for education only, we'll be richer by a lot of experiences when we walk out of there. And you need good experiences to build
Good morning to one and all. On behalf of Jain Institute of Technology, Davangere, I'd like to welcome all the dignitaries and participants. First of all, I'd like to just introduce First, I'll tell you something related to webinar. This is the second international webinar which we are hosting, and the webinar topics are forensic engineering and underground urban rail infrastructure. And I'd like to thank this webinar is in association with VTU and ICI, and I'd like to thank the VTU and the ICI for providing the associationship, and the resource persons for this webinar are Savita Dr. Savita Srinivasan, and and one more resource person is at Sri Priya Rangaraju. And now I'd like to tell something related to the resource person. Dr. Savita Srinivasan is a PhD graduate from the University of Texas, Austin. And the topic which is handled here is forensic engineering, the failure analysis. Madam has completed a PhD from the University of Texas at Austin, and our interests are like building materials, concrete strength, durability, and service life, structural health monitoring, and sustainability. And she has also worked as teaching assistant in University of Texas at Austin. And I'd also like to welcome our principal, Dr. Manjunatha T.S. sir, for this webinar. And I'll give the mic to our principal, sir, to speak few words. Sir, your mic is mute, sir. Sir, 1 minute, sir.
Hello. Hello.
Yes, sir. Yes, sir. You can just continue, sir.
Yeah. Okay. Thank you. Thank you, Professor Rohit. Very good morning to all. I heartily once again welcome on behalf of Jain Institute of Technology all the participants for today's international webinar on forensic engineering failure analysis and underground urban rail infrastructure overview and construction. Very good morning to Dr. Savita Srinivasan. Madam, thank you very much for accepting our invitation. And today you are delivering the lecture on the forensic engineering failure analysis. And I also thank Dr. Sri Priya Rangaraju for the topic on underground urban rail infrastructure overview and construction. So this webinar deals with forensic engineering, which includes the investigation of structural components that fail, causing any damage to property or economic losses. And the infrastructure of a railway is a complex and multidisciplinary engineering system, which involving earthworks, bridges, tunnels, steelwork, timber, and track system to form the base upon which the railway runs. So this Jain Institute of Technology is continuously trying to conduct one or the other way the seminars or webinars so that we can engage the students as well as the teaching faculty. So in this pandemic situation, I once again thank Dr. Savita Srinivasan as well as Dr. Sri Priya Rangaraju for accepting our invitation and for this webinar. Thank you very much, madam. Thank you. Now I leave the platform to Professor Rohit to continue the webinar with from Dr. Savita Srinivasan. Thank you, madam.
So, thank you, sir. Thank you for your few words. Now, just I'll ask Mr. Dr. Savita madam to just take over the mic.
Can everyone hear me? Am I audible, sir?
Madam, it's a bit down. Your audio is a bit down.
What about now? Is it okay?
The audio is down again. But the audio is a bit down. Yeah. The mic is mute.
Is it okay now? Can you hear me?
Yeah, madam.
Okay. Okay.
Yeah. That's
Okay. Good morning, everybody. My name is Savita. And thank you very much for inviting me to this webinar. And this is my second time, so thanks a lot. So this today's topic is forensic engineering. I'm going to share my screen now. So today's topic is forensic engineering and failure analysis. So if you're a civil engineer, chances are that someone or the other has asked you to take a look at a crack in their wall. And you also probably took a look at that wall and tried to do a quick analysis to see why these cracks were caused. And if you did, you were a forensic civil engineer. Forensic engineering is a really old science that involves the assessment of failure and the analysis of effects that arise from these failures. So in this webinar, we are going to take a look at what forensic engineering actually is and what forensic engineers do. So we're also going to have an interactive session where we're going to analyze some examples of failure and do some detective work of our own and see if we can solve these problems. So for the interactive session of this presentation, we're going to use the comments function in on Zoom. So please be aware of that, and then please do interact as much as you can. So what is a forensic civil engineering? So the dictionary describes forensics as belonging to or used or something that is suitable for use in courts. So according to ASE, that is the American Society of Civil Engineers, forensic engineering as pertaining to civil engineering is the application of engineering principles to investigate failures or other performance problems in constructed buildings or built structures. It also involves testimony on findings of these investigations before a court of law or some other judicial forum when it is required. So what does a forensic engineer actually do? So the first job that they have to do is to determine if there is a damage or failure. And the second one is to observe and report on this damage or failure. The third one is to evaluate the extent of damage or to see how much of a damage is there. And the fourth one is to provide a diagnosis of the condition of the structure. The next one is, if possible, provide a solution for repair or rehabilitation, or sometimes they'll just say this building is can no longer be saved, so please destroy it. And the last one is to provide expert opinions in legal settings. Usually this happens when you have to settle an insurance claim or when there are disputes between engineers, architects, builders, and clients. So our job is to basically determine whose mistake it is. Say there's a crack in a wall. So how do you know whose fault it is? So was there an issue with design, execution, or use? So if it's a problem with design, you'd be the people responsible would be the architects and the engineers. If there's a problem with execution, the mistake would be with the builder. Did they use the correct material? Did they follow the design instructions properly? If there's a problem with use, it means the question is, did the client misuse the item? So our job is to find out whose mistake it is and then place the blame correctly on them. So what are the skills that a forensic engineer would require on the field? So the first one is, of course, planning and organizing. So you need to know what you're investigating. So you need all this information before you actually step onto the field itself. The next one is, what kind of information do you require from your client? What is the kind of damage that is expected? What is the equipment that you would need for investigation? Do you require a subject matter expert, or are you the subject matter expert? The next one is, how much time do you need and how much would this investigation cost? Because most of these jobs are per hour basis. So the amount of time you spend is how much money you make out of it. So you need to have all this prepared in order to save money and time for yourself and for your client. The next set of skills that a forensic engineer would require is expert technical knowledge. So you would require knowledge about building materials, structural analysis. So when it comes to building materials, you need to know concrete, steel, masonry, wood, polymers, etc. Structural analysis, you would need to know design of steel, reinforced concrete, pre-stressed concrete, behavior of materials and structures under loads. And when we talk about geotechnical engineering, you need to know about foundations and soil. And then you also need to know about durability concerns and the kind of durability mechanisms that you can expect in a situation like this. You need to have knowledge about construction management and planning. You need to know how to design or to see what is the fault in plumbing, electrical, HVAC systems, etc. And you also need to know what are the testing practices that are available for you to find out what the issue is. So basically, you need to keep up with all the new technologies and the materials and methods that are available to you. In addition to just the technical skills, you also need a large amount of soft skills because you need to be able to explain technical problems to clients, which means you have to be able to explain a very technical or a civil engineering issue to a layman and be able to convince them. You also have to provide technical return reports. So you have to have good amount of writing skills as well. You also need to provide expert opinions in legal settings. So you have to be able to explain what the issue is in legal terms. So you also need to have good working relationships with other subject matter experts because you cannot obviously know everything, right? So you need to have people you can talk to or your friends or your colleagues who you can refer if you cannot solve the problem yourself. You also need to have good marketing and advertising skills so people know about you. And you also need to be able to research things. So it's so you can find out if there are problems that other people have faced that is similar to your issue at hand. And the other one is you have to have a lot of credibility. So if you make a mistake once, you lose your credibility. So you need to have a very sound educational background, that is technical skills and soft skills. And you should have the required licensing from the regulatory authorities. And you should also be an active member of technical society so you can keep up on what's the new thing that you need to know. And of course, you should be professionally ethical. So you should have avoid conflict of interest when possible, maintain confidentiality, and be very objective in observations. So you have to be very impartial. If you lose credibility once, that is the end. So making a mistake is not a crime, but hiding and lying about it is definitely a crime, especially in a legal setting. So maintaining your credibility is the most important thing as a forensic engineer. So if you want your 5-star rating, you have to make sure that your trust isn't lost. Essentially, forensic engineering is about solving problems. So if you're a fan of, say, Agatha Christie or Sherlock Holmes and you like solving mysteries, forensic civil engineering is a great profession for you. You can put on your thinking cap and solve problems while also saving lives and money. A lot of these problems that you come across will be tricky and you need to think outside the box. And you'll also have to look for innovative solutions. For example, my forensics professor once asked me how I would determine the age of a crack on a floor. And I was going on and talking about how I would find a microscope or a magnifying glass and examine the edges of this crack. And if the edges were worn out, it would mean that the crack was an old crack, while if the edge was sharp, it would be a new crack. And my professor said he would just shine a torch down the crack and see if there was any dust in it. So if there was dust, it would mean that the crack was an old crack. If there was no dust, it would mean that the crack was a new crack. So part of your work as a forensic engineer is to know how to get solutions easily and quickly. And that only comes with experience and time. So if you want to improve your skills as a forensic engineer, the best thing you can do is keep an eye out for failures always and keep trying to solve them whenever you get a chance. So if you see a crack or anything anywhere, related to buildings, and you want to try and solve it on your own and see if you can get an answer. So let's talk about failures now. So when a structure or material does not perform in the manner it was intended, it's called a failure. So it does not necessarily have to collapse to be defined as a failure. So failure can be reduced service life due to durability issues. It can be aesthetic issues where you cannot use the structure as it is intended, or when it reduces comfort to occupants. So for example, this is not a broken down building or anything, but it is still going to be considered a failure because there is water pooling where there should not be any water pooling. So how do you prevent a failure? It's very simple. So you just have to have rules on how to construct properly. And this you can do by observing previous failures and use sound engineering principles. So this building codes are the way we deal with this problem of failures, or how to avoid or reduce the amount of failures that happen in built structures. So building codes are generally developed by a very democratic and deliberative process that applies improvements incrementally, which means that each improvement or each change is made in very small increments. And it's done after a lot of discussions and deliberations. So the provisions in a code are very thoroughly examined and vetted by a team of high-level industry professionals before they're ever put in practice. And these changes happen very slowly and over time. So if you ever attended any of these sessions where building codes are discussed or codal provisions are discussed, you will see how deliberative people are. So each word is debated before it's put in. This is done generally to avoid any accidental misunderstandings that happen when a third person is reading them. So building codes can be used for both designed-in components, such as foundations, or operational and maintenance aspects of buildings, such as HVAC systems. They exist to protect public health and safety, protect the environment, improve cost efficiency, and protect against natural or man-made disasters as much as possible. So the goal is to build everything right. So you build the right thing, build it fast, and build the thing right. So our goal is to basically build it right. Codes set minimum requirements for building design and construction to protect health, safety, and natural resources. So if we look at the history of building codes, so the earliest known code that we have is the Code of Hammurabi, who was a Babylonian king in the early 1700s BC. It is generally considered to be the oldest existing building code that was enforced by law. However, it is more of a if-else system of rules for what is the punishment that should be levied if a construction failure occurs. It doesn't really give you any rules on how to construct a building. So here you can see some of the examples that are in this code. So one is if the builder builds a house which kills the owner, the builder shall be put to death. So it's more of an eye for an eye kind of a situation. Same if the son is dead, the son shall die. Son of the builder shall be put to death. So it's something like that. Technically, a code is one that can be enforced by a court of law, such as this one, because the king would usually take into account, and then he would be the one passing judgment when things like this happen. However, there are plenty of other codes in ancient cultures which were generally used to guide construction processes, even if they weren't really enforced by a law. So we'll just call these rules and then we'll talk about them as well. So here is some history of building rules from India. So we do have Vastu Shastra, which still exists, but a lot of this knowledge has been lost to time and invading forces, which has led to the engineering and architectural aspects of this that have gotten so diluted that now it's seen more like a superstition than a science. So there are plenty of other documents on building codes in Indian systems itself, which is, if you just do a quick Wikipedia search, you can see a huge number of a list of documents that can be used. So Vastu Shastra it's more like an amalgamation of a lot of knowledge in building practices from the BC period. So it provides information on what kind of site layouts exist, what materials can be used, where you can place your windows and doors, what are the ceiling heights, roof slopes, and things like that. It also gives you information on what kind of soil buildings may be constructed on, and how and when construction should be done. So it also gives you information on what is the shelf life of a lot of construction materials. Similarly, we have the Arthashastra by Kautilya, who gives us a lot of information on how to do city planning. So it gives you, the first one gives you information on how to construct moats for safety during war and siege times. The second one gives you information on how to prevent fires during in public areas. The next one is on how to construct roads and what is the width and the breadth and what kind of material should be used. The next one gives you information on what kind of stairs or how stairs have to be built. The next one is on the depth of pillars, or how deep you have to embed pillars in order for them to be steady. The last one gives you design for detailing of houses for citizens. We also have the Hebrew Biblical Code, which gives us a few rules on how to construct buildings. So the first one gives you information on the safety aspect of how high parapets should be on the roof. The next one gives you information on how to prevent mold, or how to fix mold when it occurs. We also have Feng Shui from China, which gives you information on site layouts, building materials, where to place windows and doors, ceiling heights, what are the items that you can use to guide energy within a dwelling, how to construct woodwork, wood-based items, and also how to design landscapes. So those were just history of olden codes. And so now we can also talk about the history of more modern codes. So after the Great Fire of London, UK enacted the Rebuilding of London Act, which had a lot of information on how to construct buildings safely. There was also urban planning rules for Spanish colonies when they were invading other countries, or called the Law of Indies 1680. And then there was also another London Building Act, which was built upon the Rebuilding of London Act by the National Building Code in UK again. We also have the Uniform Building Code by the International Conference of Building Officials, which is a legacy code for most of the present day building codes that we have. We also have the latest International Building Code by the International Code of Council. So the International Code of Council is a non-profit organization that provides a wide range of building safety solutions. So this also includes things like product evaluation, accreditation, certification, and training. And it develops model codes and standards that other countries adopt to construct safe, sustainable, affordable, and strong structures. So here are some building codes from around the world. So the first set is the legacy codes. So these are old codes that were developed that are the basis of all our new modern codes. So we have the BOCA National Code, we have the Uniform Building Code, and the Standard Building Code. So all of these are the ones that we tend to use these days. So Australia uses the Building Code of Australia, and this is just a list of the different codes that different countries around the world use. So this is the code that India uses. That's the National Building Code from 2016. So it generally provides us guidelines for regulating building construction activities throughout the country. And it serves as a model code for adoption by all agencies, that's Public Works Department, government construction, other departments, local bodies, and private construction agencies. So it contains a large amount of regulations on fire safety, and then material, structural design, construction safety, building and plumbing services, and sustainability, among other things. So how does failure occurs? So the first mode of failure that we talk about is design failure. So this is basically improper design of element or structure. So this can be structural, it can be a durability problem, it can be functional, or it can be aesthetic, or it can just be a really bad design. So the next one is event failure, where this is a one-time external failure. So it can be natural disasters or man-made disasters or usage errors where you have improper use. For example, here, a tank that should not be going on a bridge has gone on a bridge and destroyed it. The next one is mode failure. This occurs from design defect or by repeated events. Basically, when you have wear and tear, durability problems, or fatigue issues, or repeated impact loads, you can see something like this, a bridge that is collapsed due to corrosion occurring. The last one is mixed mode failure. This happens when two or more of the previous kinds of failures occur together. So for example, a steel bridge is corroding and it experiences an earthquake, or an aging pier is showing signs of leaning and is overloaded, or an improperly nailed roof gets ripped off during a tornado. The other one is you can see rainwater that's pooling on a roof, which causes mold, bloating of plaster, and spalling of masonry. For example, here's the Tacoma Narrows Bridge, which had a really bad design, and it was followed by heavy winds, which led to the bridge collapsing. So how do you determine the cause of failure? So there should be a clear methodology. So your method should be rational, it should be systematic, it should be defensible, and it should lead to the truth. So the way we do this is using the scientific method. So the first step in scientific method is you state the problem. The next one is you make observations, develop a hypothesis. So when you develop the hypothesis, you're going to test your hypothesis by you make more observations, perform calculations, do some lab testing, and you research. So you can find previous cases similar to your present case using research. If this doesn't lead to a solution, you start over again, and then you go back and start developing a new hypothesis. And you repeat these steps until you get a probable solution, and you develop conclusions for this likely cause. So this method gives you a reasonably accurate guess on what the probable cause of failure is. It is impossible to determine the actual or true cause of failure each time. So what you're looking for is the most probable cause. So there are several methods that are available for failure analysis of structures, and I'm going to list some of them here. Each of these is a topic on its own. So we're just going to take a look at these. So from now, we're going to start discussing some actual failures. So the first one is a leaning tower. So the Leaning Tower of Pisa is one of the most famous failures, but leaning towers are quite common. The most famous one, though, is the Leaning Tower of Pisa, that it was a design that was flawed right from the beginning. So it was a 200-foot tower that's tilted at a 5.5-degree angle. So the tower began to sink right after construction had progressed to the second floor. The foundation depth was around 3 meters. It was built on very weak and unstable subsoil. And to compensate for the tilt that started appearing when it was in the second floor, the engineers started to build the upper floors with one side taller than the other. So the final tower sort of ended up being curved. So one of the really cool things about this tower is that it has experienced at least 4 strong earthquakes since 1280. But this tilting, apparently very vulnerable tower has survived this long. And researchers were very surprised, very excited to know why. So they sort of started researching it. And they concluded that the reason was because of the dynamic soil structure interaction under the tower. So the height and the stiffness of this tower, along with the very soft subsoil that was there, influenced the vibrational characteristics of the structure in such a way that when the earthquake occurred, the building did not resonate with the earthquake motion. So basically, the same soft soil that was causing this leaning problem was also the one that's helped it survive this earthquake. So after nearly 20 years of studies, people started to sort of see why, what the problem was and try and fix it. So what they did was fill soil under the raised part that was removed. And then they also stabilized the soil under the sunken portion. And they also placed counterweights to prevent the tower from tilting anymore, and also attached anchoring cables to the third level. So this next one is the Tacoma Narrows Bridge that we spoke about earlier. So this is a very famous failure that was caught on camera, which is something that doesn't really happen a lot. But it has been used as an example of what not to do or how not to construct a bridge in physics and engineering classes for nearly 60 years now. And the bridge was nicknamed Galloping Gertie for how it moved when it was about to collapse. So the bridge sort of showed extreme movement whenever there was any wind once the deck was placed. And this was before construction was even completed. And the workers sort of complained that there was an issue with the bridge moving around each time there was any wind. So during construction itself, a lot of damping measures were adopted to prevent this wind problem. But however, after 4 months of opening the bridge, the deck started to shake in a very twisting motion when there was a heavy wind. And this motion sort of slowly increased in amplitude, and the deck just ripped apart and fell into the river. But there were only 0 dead and 0 injured. So in this picture, you can sort of see how the bridge is starting to move and twist in the wind itself. And this is after the bridge just collapsed right into the river. But because how slow the amplitude increased, people had time to get off the bridge. So the death toll was 0, and there were no injured people as well. The next one is the collapse that happened at Hyatt Regency in 1981. So till now, we talked about failures that didn't have any casualties, but that's not always the case. Some of these building failures can have very disastrous results and can cause a huge loss in human lives. So this was an elevated steel walkway in the entryway of this Hyatt Regency hotel that collapsed during a party. So the walkway wasn't constructed properly and was loaded beyond capacity, which led to the collapse. So it ended up killing 114 people and injured around 216 people. So guests could hear popping noises moments before the 4th floor walkway collapsed and fell onto the 2nd floor walkway. And victims were sort of trapped under this tons of rubble before being rescued. So the fire department couldn't even remove this large quantity of rubble. So they had to ask volunteers to bring construction equipment to help move all of this stuff. In addition, the sprinkler system had activated because of the dust, and it flooded the whole building, putting trapped victims at a danger of drowning as well. Visibility was really bad because of the dust, and they had to keep the power turned off to prevent any accidental fires or electrocutions because of the water as well. So they had to ask people to donate generators to keep the power running and things like that. So it was a pretty bad disaster. So the walkway was supposed to be suspended on continuous rods, so something like this, where the load on this, the bolt here was only going to be P. That is the self weight of this, or the load that's going to be on this walkway. But what happened during the actual construction was that there was the design was changed during construction to include 2 sets of rods. So what happened was you had one rod coming down here and then another one here. So the amount of load on this one bolt ended up being 2P instead of being the 1P, which was supposed to be the original design. So the two sets were now connected. The fourth floor and the second floor was now connected to each other using this kind of system instead of this system. So the fourth floor beam had to support the weight of both the loads, both the fourth floor slab as well as the second floor slab, along with all the people that were on it. So the manufacturers of these rods had issues at the time that these rods might need to be threaded the entire way. So this could be damaged during the when the walkways were hoisted and constructed. So to avoid that, they switched it to this design method, but they did not do the structural analysis part of it very well, which led to this error here happening. So on this day that the walkways were fully loaded, it just collapsed, causing a lot of death and destruction. So what are the causes of, one second. There's another failure here. That's the Pier 34 collapse that occurred in early 2000. So this pier in Philadelphia collapsed. And the nightclub that was at the end of this long pier collapsed into the river, and 41 people died. 41 people fell into the river, and 3 of them ended up dying. So the pier was originally constructed in the late 1800s and was expanded in 1900. But in 1978, they estimated the lifespan to be about 12 years. So in 1992, when a nightclub was opened, the pier had already crossed its service life. And in 1994, a dive survey was performed, and they found that a few of these piles were leaning. And it was suggested that the piers be rebuilt. However, this suggestion was rejected by the owners. And in 1999, they saw a crack, a 1.5-inch crack, but surveys were not conducted to save money. And a 4-inch crack that appeared in the pier was discovered by using sheet metal just the day before the accident occurred. So this is what the intended structure was, but this is what happened. This is what was happening when the structure actually collapsed. So here we're going to list what the probable causes of failure were. So the first one is that it's possible that these pilings may be damaged by exposure to heavy ice buildup the previous winter. The next one is that there were probably cracks in the surface, and the damaged seawall sort of led the pile to go out of alignment. The next one is that these old piles were not protected against pests, so they had to suffer countless wetting and drying cycles, which would have weakened the wood. And the last one is that it's possible that during high tide, the water which was acting as a brace to protect this deck wasn't there during low tide, which led to the support of the water not being there, which would have caused the collapse. But after a lot of investigation, they were trying to see what the most probable cause was. So the actual cause of the failure was never found, but the following causes were probably most likely. So the first one is that the old wood had started rotting because of the wetting and drying cycles. This was actually found out even before the accident was conducted. The next one is that the seawall cracked, allowing the infill to escape, causing the piles to start tilting. The next one is that the low tide caused additional stress on the pilings, and the bracing that was offered by the water was lost. And it's also seen that the pine poles were already leaning before the collapse, and the piles were found cracked at about 2/3 height. So the evidence sort of showed that the pier and the manager of the club were aware that there was a lot of danger of collapse, but they didn't really do anything to prevent the problem. So they were charged with third-degree murder, causing reckless endangerment and failure to prevent catastrophe. So during deliberations, even the jury wasn't able to come up with a proper decision. So they sort of settled the case out of court by just giving the victim some compensation. So things like this, if you don't look at, or if you're not maintaining your things properly, also it is your fault. So you have to be very careful about things like this. So let's talk about what are causes of building failures. So we already saw some of these very dramatic failures, but most of the failures that we come across in our actual life are pretty mundane. They're not this dramatic. So most of it is caused by things like long-term durability issues like corrosion or freeze-thaw, ASR, DEF, things like sulfate attack. And in addition, it's also things like improper detailing or inadequate codes, or when people are reading these codes, they don't understand it properly. There's also improper construction practices where there's an emphasis on trying to save money, so things are not constructed well or materials are not used properly. The other one is improper inspection during construction or improper usage of these constructed facilities. There's mistakes, errors, omissions, uh, lack of communication and coordination. And one of the bigger things is the lack of maintenance once the building is constructed. So most of it comes down to ignorance, incompetence, and inexperience. So our job as designers or engineers is to make sure that everything we design is, checked multiple times, and we cross-check it with other people who know better as well. So we're at the halfway mark, so we'll stop for a little bit and have some questions if there are anything. Dr. Rohit? If there are any questions, please feel free to type them in the chat box so I can answer them. So we're going to take like a 10-minute break now. Okay, there's a question here that says how we can prevent from failure. So we just talked about how we can do that. We talked about how to use building codes and how to be more careful while designing to be able to prevent failures from even happening before they occur. The next question is, what is the scope for forensic engineering as a profession? The scope for forensic engineering as a profession, there is a lot of scope because it's a new and upcoming topic right now. So it's definitely there, and it's a good consultancy profession for people who are interested in doing something part-time, or it's a good profession. But right now, I don't think it's there as a full-fledged profession, but you can always work with people who do structural health monitoring and things like that. Where is debris dumped and what later? So where is debris dumped? As of right now, most of our construction and demolition waste ends up going into landfills, or they're just thrown around, empty sites and things like that. So that is a problem that needs to be solved, but that is not, again, a forensic engineering problem. That's more of a waste management issue. The next one is, please explain the pressure calculation on the pier. So the pressure calculation that I was talking about was not on the pier. It was on the tie rods that were in the walkway. That is more of a structural engineering question. I would suggest reading up on that disaster a little more on your own time, because that's something, if I take up now, will take a lot of time, and we don't have that much time, right? There's another question that says how to construct a pillar. So if you want to construct a pillar, please refer to the building code. We have the IS 456 that gives you all this information. Then the next one is, may I know an example of failure of building because of material in India? I don't have an example right now, but you may contact me later and I'll see if I can find something for you. The Tower of Pisa is inclined due to softness of soil only. That is one of the biggest issues that one side started thinking because the soil underneath was very soft. And there was also a problem that the foundation wasn't deep enough. It was only 3 meters for a tower that was 220 feet high. Okay, there's a certificate link that please ask the organizers, they'll give that to you. Same for the feedback link as well. Are there any courses which teach forensic engineering in India? Not that I am aware of, but you can always contact me if you need to. And good practices to prevent failure. First one is, of course, be very familiar with the codes and the engineering principles. Be when you're studying, be very dedicated when you're actually reading. All your basic courses are very important. Things like engineering mechanics, your RCC design, pre-stress design, steel design. Those are very important concepts that you need to be very clear on if you want to build a structure that won't fail. So obviously, good practices are be knowledgeable, be keep track of what you're doing, and keep reading the codes and see things like that. Please describe the types, location, causes of structural cracks developed in structure like bridge. This is a very loaded question. That's a 1-hour webinar on its own. So I'm going to leave that for now. Concrete demolition waste is being used, I agree, by using recycled aggregate and all that, but the amount of concrete waste that is recycled is very less compared to the amount of concrete waste that is actually generated. So you're absolutely right with this thing about using recycled aggregate and using the waste dust that's produced. Have you been involved in geotech? Not really. I am not. I don't have a geotech background at all. So my relationship with forensic engineering is more on the materials and concrete related. So geotechnical engineering is not really my strength at all. Any limit cracks are except on green concrete? If yes, please refer code. I'm not sure what this question means. Are you asking me if what are the crack limits accepted on concrete? I think that would be the same as for any other concrete, right? So please, the IS 456 should give you information on what the restrictions on crack limits are on everything. Please explain the soil structure interaction. Again, this is it's a geotech problem. That's not really my strength. So if you need more information, all of it is really available online. Please look that up. Is there an opportunity as a career? Yes, there is, because of course there's a lot of failure that happens, building failures that happen in India, and even in India now we've started, started having things like insurance claims and finding out whose mistake it is, because then that's the only way you can claim insurance appropriately. So yes, there is an opportunity for career in India, but it has to be something that we develop on our own. So. Instruments and equipments used for tests. Again, there's a fair amount of non-destructive tests that are available. There are also destructive tests that are available. That is a different topic. Again, it's a long, big topic. So how much do you charge for your webinar, please? If you're interested, please, contact me on my email. I'll be providing it later on, and we can talk about that on a private chat. Thank you. Forensic engineering, as far as I know, there isn't a specialized course in India right now. So you can, you can always take online courses, or you can go abroad if you're interested as well, because the US definitely has, as well as the UK, both of them have very strict forensic engineering courses that you can take, and they're pretty interesting as well. how to work part-time career in this field. Actually, even I would like to know, because I want to do a part-time thing as well. If you know, please let me know. Sudden rupture or cracking occurs in road or building. How does it happen? So sudden rupture or cracking, frankly speaking, you will not really have sudden rupture or cracking unless it's an external one-time event that happened. Generally, when you see cracking, it means that issues have already happened inside your structure, and it's your job to see where this issue happened and why this issue has happened. So what you call a sudden rupture is not really sudden. It's just it's like a symptom, not the cause of the problem.
Madam, sorry for the interruption, madam.
Yeah.
I kindly request the participants to just ask the relevant questions. Madam.
So after in another minute or so, I'm going to stop and then start continuing. So we'll look at the rest of the questions later on.
Yeah, madam. Will you start with the session?
Yeah, I'm going to start with the interactive session. So I'll keep the chat box open here, so people can still keep asking questions.
Okay. Right.
But for now, I'm going to leave these questions and we can tackle these once we're done. Is that okay?
Yes, madam. Okay.
Yeah. So now we're going to start with the interactive session on failure modes and effects. So what we're going to do now is I'll show you pictures of failures, and then we can have everyone take guesses and see which is the most probable cause. Is that okay? Okay, so that's the first one. What you can see here is some images of cracking in a wall. So this is a building that was constructed in 2003. So it's an RCC frame structure with brick masonry infill. And the wall that you see right now is a non-load bearing wall, which sort of developed diagonal cracks across the entire depth. And the crack width was around here you see it's about 0.5 centimeter wide here, and the cracks sort of go through the entire depth of the wall as well. So these cracks were grouted immediately right after they appeared. So they first appeared after the first monsoon season, right after construction. So originally there was a wall perpendicular to this damaged wall that had even larger cracks. And this perpendicular wall was then removed as the damage was deemed beyond repair, and a lightweight aluminum partition wall was placed instead. But even after that, the next year, immediately after the monsoon season, the cracks appeared. So this is the plan of the wall. So this is the damaged wall, the picture that you're seeing, and this is the wall that was initially there, the perpendicular wall, which had even higher cracking than this one. So what we're going to do now is list out the possible causes. So the reason that I know all this information about this crack is because these were cracks that appeared in my own study room in 2003. And I looked at these cracks for years and only did a failure analysis in 2015 to track down the cause. So the first possible cause that we have here is that it's possible that high diagonal stresses were developed because of this additional wall that's there that was pulling the damaged wall down. The next one was that it was possibly a differential movement because of non-uniform movement between these two components. The next one was differential settlement because of the supporting soil under the foundation of this wall. The next one was there any external load inducing torsion because of this perpendicular wall that was pulling it down? The next one is, the last one, of course, was moisture expansion because of absorption of water. So to see what the most probable cause is, you want to look at multiple aspects. So the first one you want to see is when did these cracks appear, at what time? So what we came up with finally, the solution was that it's the differential settlement of supporting soil, because these cracks appeared and widened during monsoon. So it's highly likely that these cracks were because of this expansive clay that the wall was built on. So originally what we assumed was that the perpendicular wall that's here, this wall is what was pulling this wall down, causing the cracking. But even after that wall was removed, it still showed cracking. So that's why we sort of decided that it was the soil which was causing the problem. So that one is the first one. So I gave you a general idea on how to go through the scientific method and then find out what the cause of cracking is. So the next ones, I want everyone to start taking guesses on what the probable cause is. So this one is delamination of plastering from masonry wall. So this, what you see here, all of this plastering is delaminated from this masonry wall. So if you want to take guesses on why that's being caused, you can let me know. Please use the chat box for your answers or for your guesses. Okay, there's a lot of questions, things that are saying dampness, and then there's a freeze and thaw here, subsidence. Okay. Lack of curing, yes. Capillary action is also possible, yeah. Again, that's related to moisture. Yeah, that's also another thing, that there is hacking is not done correct. For surface preparation, true. Shrinkage, yeah, that can be a possible thing. Poor cement sand ratio, yeah. Creep, we're talking about plastering here, so creep is probably not something. More silt content in sand, sulfate attack. No, so if you're looking at sulfate attack, you would see a different kind of damage. You'll see not delamination, but more of a melting that happens. Okay, improper mix, low distribution, soil bearing capacity. It's more of a delamination problem. So I think it's not about soil and foundation design here. Brick strength, again, it's a delamination problem. So brick strength is probably not an issue. Lack of moisture could be. Bad workmanship, most likely. Efflorescence, probably not, again, because you don't see any efflorescence here, right? So it's not something that's there. Surface bonding, yes. Temperature, yes, because there's a fair amount of sunlight that is reflected on this wall, so yes. Water cement ratio, again, yeah. So yeah, so let's look at the most probable causes. First one, of course, is moisture absorption due to capillary effect. In overlay, because we can clearly see that there's no again hacking done here, but so to create a good bond between these two things. And of course, last one is the incompatible thermal coefficiency that could be because of between the underlay and the overlay, which can lead to delamination occurring. High sound waves falling on the wall continuously, I don't think that's a problem, because this is a residential area. Okay, so we'll go to the next one then. This one is cracking that's occurring in an external roof slab. So again, you can start taking guesses on why this cracking might be happening. So what I have listed here is only a very small list of causes. So I would like everyone else to also take more guesses on what the problems could be. So this is heat of hydration. Probably not, because it's not really that much of a large concrete thing, right? Temperature stresses possible. Thermal cracks, yes. Impact, Probably not, considering that it's you don't see an impact here. Corroded rebar. Corroded rebar is possible, but again, you don't see any corrosion happening here, right? Thermal expansion, again, plastic shrinkage is possible. Water cement ratio, yes, again, that's because of your plastic and drying shrinkage. Thermal expansion, condition of fixity. This is more of a material problem rather than a structural problem if you look at it. Elasticity, poor quality of cement, plastic shrinkage. Again, see, things like poor quality of cement is hard to determine when you're just looking at a picture. Because you don't know what the water cement ratio was, or what the quality of cement was, right? Moisture loss from concrete, yes. Lack of curing, this is a problem. Thermal expansion, heavy moisture. So you're suggesting that there's water pooling on the roof, which is causing this? Could be due to porous action by change in climate and atmosphere. Yeah, that's also possible. Change in temperature, poor structural design, mixing ratio, improper cover. Improper cover, again, we don't know because we don't know what the cover is. Rain. Yes, so the list of probable causes that I have here is, first one is thermal stresses due to exposure to sun because it's a roof. Next one is drying shrinkage, and the last one is lack of expansion joints. So this is a problem that we see in a lot of large concrete structures, that we don't put in expansion joints. We tend to assume that a small roof doesn't require it, but we do need expansion joints to prevent cracks, like drying shrinkage cracks, as well as thermal cracks from appearing. So we'll go to the next one. So this one again is cracking in a masonry infill wall in an RCC frame structure. So I'll sort of highlight the cracks so you can see them. So what you see here is, this is a column and this is a beam here. So what you see is that there's cracking that's happening at the edges of these columns and the beams. So I have a few probable causes listed here. You can always try and add a few more. So I think there's someone who's asking, is this ready-mix concrete? No, it's not. Poor detailing at spacing not maintained. Yeah, that's possible. Water absorption, heat of hydration, poor detailing, improper cover, deflection, bond with vertical bars, settlement crack, shear failure. Yeah, all of these are possible solutions. Any more that we can think of? Actually, one of the most common reasons that this delamination between masonry and the concrete happens is because your mortar joint tends to shrink after some time, which causes this delamination between the wall and the RCC part of the building happen. Okay, here's the next one. Again, a very common problem that we see all around. When you have these long walls, so you have cracking in a 40-foot long masonry compound wall. So here's a closer picture where you can see the wall sort of move completely. Someone's taking guess saying expansion. Yes, uneven settlement is possible. Yeah, temperature is a problem because you have thermal stresses that will happen in a wall that's that long. So when you don't have expansion joints, you have this problem that occurs in masonry quite often. this again is a problem that can be very easily solved by putting expansion joints at regular intervals, depending on the thermal stresses that will be in your structure. Again, yes, soil settling and settling of foundation, differential settlement is another cause. There's also the problem that sometimes there's not a good enough bond between masonry units. Yeah, bad quality of bricks is also a possibility. So we can move to the next one. So this one is seepage through a concrete retaining wall. So you can see the wetness that's coming from the infill at the back into this concrete retaining wall. And we want to see what is causing this problem. So here you can see a more close-up of the seepage that's happening. Yep, that's correct. No seepage holes. So what you can see here is also this small drying shrinkage crack that's showing up in this retaining wall that's the source of all the seepage problem. So yeah, so there is, of course, all of these things that you're saying here, there's not enough weep holes, correct? But the main issue, of course, is that your concrete itself is cracking because of drying shrinkage. Right, let's move on to the next one. So again, this one is cracking in a masonry wall. So you can see the crack highlighted here. So we have the roof beam and the masonry again. So you can, again, similar to the previous problem where we have the main issue is that there's shrinkage of a mortar joint that leads to this delamination between the masonry and the roof beam itself. So yeah, this is the next one. So we have the problem summary here. Again, we see a cracking at a beam slab connection. So yeah, improper joint is a problem. You can try more. This one is actually a very obvious solution because you can see the corrosion products that are sort of flowing out from here, the brown rust that's coming out from the roof slab. So this one really doesn't require a lot of a list of causes or anything because you already see that reddish brown corrosion product, which is proof of the problem itself, right? Because now when you have corrosion, the corrosion product, which is rust, has a larger volume when you compare it to iron or steel, which leads to expansion on the inside. Again, which leads to cracking and spalling and delamination and things like that. So this one, anytime you see this corrosion product flowing out like this, you can easily just, not even worry about anything else and just say corrosion. Okay, this next one is it's a very simple one. We have cracking in a concrete slab. So I've highlighted the cracks for you. These are 4 big ones and then 2 small ones. So you can take a guess on what could be the problem here. Thermal expansion, impact loading, yeah, those are options. But you can sort of see that there's a good joint here, so thermal is not really an issue. Shrinkage, lack of curing, yes, could be a possible. Lack of vibrator using, yes, probably, because the concrete might be segregated. But there's an easier or a more clearer solution for this, or a probable cause. What you see, so we can sort of see what are the possible probable causes that I have listed. So I have impact loading, fatigue loading, differential settlement, freeze thaw, and the last one is is the stress concentration at the edge of a square. So it's very simple. So whenever you have a square design like this, you have more stress concentrated at the edges, something like that. So that's why it's suggested that we use a more circular design when we want to put manholes or anything, because this prevents the stress concentration at the edge and you have a more uniform stress concentration that happens. Okay, we have 2 more to go. So this is example number 10. So we see cracking at the edge of the concrete pavement. So if this is probably familiar to some people, this is very common in concrete pavements. If you've seen it, you will always know, but if you have not, this might be something new to you. So I'll highlight the pattern of cracks that appear at the edges of these concrete pavements. So someone is asking me, what is freeze thaw? Yes, so let's look at the probable causes. So we have thermal stresses, fatigue loading, impact loading, stress concentration at the edge of a square, or freeze thaw. So this is very symptomatic of freeze thaw damage. So whenever you see these kind of D-shaped cracks that appear on the edges of concrete pavements, you can be sure that this is freeze thaw. And this can be easily solved by using higher percentage of air, of entrained air in concrete. So this is very symptomatic of freeze thaw. So whenever you see these edge decracking, you can easily say that these is freeze thaw. And you tend to see these only in places that have freeze, that where temperatures fall below freezing temperature. This is the next one. So this one is simple cracking in a concrete sidewalk. Again, cracks highlighted. Looks like I've moved the figure a little bit, sorry. So here we have the list of probable causes, differential settlement, because this is a concrete sidewalk, freeze thaw, again, stress concentration at the edge of a square. If there's anything more, you can always try and take guesses as well. Impacted edge, possible, yeah. There's actually a very nice clue right here with this anchored cable here that you can see that from where all these cracks are emanating from. So it's basically just that this anchored cable is putting a tensile force on this concrete sidewalk, which is causing these flexural cracks to appear at the edge. Okay, this is the last one. So we have some crocodile cracking that's appearing in a concrete retaining wall. So this one is, again, if you've seen this, you will know immediately what this problem is. But if you haven't, you'll have to sort of think about it a little more. So yeah, if you've seen it, ASR crack, someone's already taken the guess. So it's a very obvious ASR crack. So I did have a few more things. I had things like differential settlement and freeze thaw written here. So again, expansion of what? So what we have here is a telltale ASR problem. So what you have is, it's just reactive silica aggregate that reacts with the OH minus that's in the concrete pore solution, which then reacts with sodium and the potassium ions, forming the alkali silica gel, which absorbs the surrounding water and expands, which in turn causes internal stresses, which causes this cracking. So someone just asked, what is an ASR crack? I think I just explained what an ASR crack is. It's alkali silica reaction. That happens when you have a reactive silica aggregate that reacts with the OH minus in your concrete pore solution. Okay. So when ASR becomes too much, this is what ends up happening. So you have a large amount of expansion that happens, huge cracks, and a lot of spalling that ends up happening. So we'll end the interactive session for now, and I'll just summarize the presentation, and we can move on to the question answer session. So of course, the first one is that forensic civil engineering is the application of civil engineering principles to investigation of failures or performance problems in built structures. And failures can be caused by improper design, construction practices, or catastrophic events, or regular wear and tear, or a combination of one or more of these. The next one is forensics engineers tend to determine the most probable cause of failure by using the scientific method. So they use their findings to provide solutions to problems or to help arbitrate legal issues. We need a wide range of technical knowledge. So you need information about building materials, structures, geotech, durability, construction management, planning, design of different elements, and testing practices. We also need social skills. We need planning, organizing. We should be able to describe technical problems to laymen. We need to be able to provide legal reports. We need to provide technical written reports. You need to be able to provide credible expert opinions in legal settings, and maintain a good working relationship with other people. So most importantly, a forensic engineer needs credibility. So trust, if you lose it once, you can never get it back. So the ultimate engineer, the goal of a forensic engineer is to improve safety and save lives and money. So that's it. That'll be the summary, and I thank everyone for their time and patience, and for doing a very nice interactive session as well. And I think I'll open it back up to questions again. Is that okay, Rohit sir?
Yeah, madam. Yeah, that's fine. Just you can go ahead with the question. Yes.
All right. So again, we can start with questions. Length or distance at which expansion joints, again, it very much depends on your structure. So depending on how wide, how thick it is, we will calculate the thermal coefficients and then use that to determine what your expansion joints should be. Okay. Again, like I said, expansion joints very much about, it is very dependent on what your structure is or where you are. It also depends on what the ambient temperature in your location is, what is the amount of temperature change that your material goes through, what is the difference in coefficients between one material and another. So you will have to calculate each of those based on your specific project itself. How can we differentiate between structural cracks and non-structural cracks in failure by forensic investigation? Again, so if you want to see, it will kind of depend on what kind of cracks you have and where they have, or if it's mostly about depth. You just look at how deep your cracks are, and if they're going right down to the center or they're crossing that, they're structural cracks. And if they're only on the surface, that they're non-structural cracks. Okay. Forensic engineering helps to improve geological properties. Forensic engineering does not do that. So forensics is all about looking at a problem and then finding why that happened. Providing a solution is only the second part of it. That's done only if your client requests it. Your primary job is to find out what the problem is. Should we do a higher study in a specific field, or is B? Forensic engineering is a subject that comes with, it's about experience. It's about how many cases you see, how many cases you solve. So it's not, you can't just take a course and then say, okay, I'm a forensic engineer now. To be a forensic engineer, you need to, work under somebody who does this as a job and gain a lot of experience, and then you can go out and do your own thing. So I don't know if you, I'm not going to say you need to go take a master's course or a PhD course in this subject. I'm going to just say that it's something you get that comes with a lot of experience and looking at a lot of different projects. Economically, rehabilitating an old structure is better than constructing a new one based on forensics findings. I don't know if this is true for everything. But I would say, yeah, there are some things where rehabilitation is better than trying to destroy the whole thing and rebuild it. It of course, depends on a case-by-case basis on whether or not your problem is a solvable one or it's something that you cannot solve. Prevention method for all these failures. Failure prevention is a whole subject on its own. It's a full semester's worth of coursework. So this is not something we can discuss right now. In case of replacement of reinforcement by bamboo, how will bondage of bamboo be with concrete? I am sure that there are people who know about bamboo construction, but I don't really know that a lot. So you might have to look up for this somewhere else. How long is the building stable after repair or retrofitting? So again, the service life of your structure will be given as something, say X years when you construct it. And then it undergoes some repair, rehabilitation, to retrofitting, and then they'll give you a new estimate on what your structure's new service life is. So again, it very much depends on how much of a retrofitting you've done, how much of rehabilitation has happened, and how long. It's basically your engineer, the person who did the job for you, will let you know what your remaining service life is. How can we detect the crack for underwater piles? So underwater piles, again, you have a lot of structural health monitoring systems that you can use to see, to detect cracks underwater. So there are a lot of GPRs and things like that. Recent advancements to prevent failure. So preventing failure doesn't really require recent advancements for anything. Preventing failure is about not making design mistakes or not misusing your structure in a way that it was not intended to be used. So I would say recent advancements, of course, there are new materials, new test methods. There's a lot of things that you can do. But yeah, there are things you can always keep looking up. New methods are there. But preventing failure is about having enough knowledge and not making mistakes. That's the main thing. How do we calculate plastic shrinkage cracks and what is its normal depth? So if you want to characterize cracks, you have width, depth, number, index, density, things like that. So you will characterize your cracks using one of those. And what is a normal depth? I don't think there is a normal depth, but it kind of depends on what your cover is, what is the strength of your concrete, where is your concrete. If you're going to put your concrete in a marine environment, you of course don't want any cracks. So it will all depend on things like that. Joints are provided after concrete is laid. Is that the correct way? So if you forget to put your concrete joints before you finish laying it, you can always cut the slab and then add a joint. That is something you can do. But it's always better to build it right the first time. So you might want to put in your joints before, ideally. Is forensic engineering related to NDT? Yes, a lot of forensic engineering is related to NDT because we tend to use non-destructive testing quite often. We also use destructive testing as much as possible. But if that's not possible, then we tend to use NDT a lot because you do need to find out why there's a problem happening or how there's a problem happening, and that does help. Crack limits mentioned at loading, which code refer Okay, so if IS 456 doesn't have the information that you're looking for, you can always go look at building codes from other countries. You can look at BS codes, you can look at American codes, or those are the two ones that you can refer to easily, or Euro codes are also available. So if you cannot find something in an IS code, those are the other three that you can look at. Why is forensic engineering important? It's so you can, prevent people from dying and save money and time for people. If there's a failure that's happening, you want to know why it's happened or how it happened, so you can prevent it from happening the next time. If we provide joints and masonry walls, how could it impact on the interior design? So interior design wouldn't matter because you would just put plastering over it, so that's fine. So collapsible soil, again, I'm not a geotech expert, but most of the times you just stabilize the soil and that should solve all your problems. But I would be better to consult with a geotech professional before you do, before you want to try any of this. Yeah, so I think we'll stop the session. Is that okay, Dr. Rohit? I think I've answered all the questions.
Okay, hi, Dr. Savita. This is Dr. Rahul Patil.
Hi, sir. Hi.
Yeah. Hello, can you hear me?
Yes, sir. Yeah, please go on.
Okay. Thanks for giving a wonderful presentation. Okay. And I would like to take an opportunity on behalf of Jain Institute of Technology to thank you once again for the session. And really, it was an insightful presentation. Okay, we are hoping for the best, and you have given a nice session. And the participants have got and have gained a lot of knowledge. I hope so. Okay, behalf of them, again, I wish to have you once again in coming webinars. Okay, and because this is a second webinar for you, and I think so I have disturbed you because of your busiest schedule. I heard that recently you got married also. So
Yes, sir,
thankful. Yeah, and behalf of our faculty members, behalf of department, behalf of principal, and I would like to thank our association partners like VTO as well as ICI also. Okay, behalf of them also I would like to thank you. And I saw a lot of what we call it as questions. The participants are asking presentations also. Okay, the PPT, if you are having it, please let us know that, so that even we can mail them.
I've already sent you the handout, sir, so you can, share that with people.
Yes, I will speak to our coordinators, okay? And I will come back to you again, okay? And it was really a good presentation. I heartily thank you once again. And first of all, I would like to thank you for accepting my request, because within one call only you have accepted the request, okay? It's my pleasure to have you here now, okay? So on behalf of Institute, once again, I'm thanking you. And I ask our coordinator as well as our Rohit to wind up this session. Okay, before that, if you want to speak a few words, you can speak. Savita.
Yeah, I just wanted to, thank you again. Like you said, it's my second time. So thanks a lot for inviting me again. Also thanks to the principal and yourself also, sir. I mean, I interact with you the most. So thanks a lot for, keeping everything comfortable and very, pleasant for me also. Thank you so much.
Yes, Savita, thank you. And the participants also, if you have any questions, please drop the message in YouTube also. You can have the interaction session. Later, if there are any important questions, even we can ask our Savita, so that even we can reply you people. Okay. So here we conclude the session. Once again, thank you, Savita. Okay. We'll let you know other things later. Okay.
Sure.
Thank you. Okay, but
Yeah, thank you, madam. Thanks for the presentation, and thanks for all the participants for patience hearing. Thank you. tomorrow the session will be starting at 10:30 sharp 10:30 or 10:15. You can just log in.
One more point, Mr. Rohit.
Yes, sir.
I would like to ask our participants that tomorrow there will be again a wonderful session. Okay, it is an underground rail infrastructure. So I hope so you people will join once again tomorrow, and we'll have a nice day tomorrow also. Thank you once again. Thank you all of you.
ಮಾಡ್ತೀರಾ?